Hello, good evening. Today is December 2nd and it's around 7:45 p.m. United States, Dallas, Texas, Central Standard Time. And this is a recorded presentation, and I will be giving the keynote address live at the IEEE ICDM conference for the Women's Forum, and that will be in about half an hour. So, my presentation is around half an hour, which I will record just in case there is a technology glitch, and then I will give this live presentation. I'm Bhavani from the University of Texas at Dallas, and now I will share my screen. Okay, so here is, yes, I'm sharing my screen now. Okay, so the title of my talk, first my research, and that's in artificial intelligence and cybersecurity, integrating it. And then I will talk about an ideal career for a woman and underrepresented minority communities where you have the best of both worlds. Okay, so AI and security. And also towards the end, I will talk about uh, how women can achieve career success. Okay, so so my talk is big data. First, I'll talk about big data security and privacy, but I'm only going to talk about the bullets in red. So ensuring the privacy of individuals and privacy enhanced data science. So I'm essentially using the word AI, machine learning, data science interchangeably. And the second topic, I'll talk about insider threat detection, some of our work on applying machine learning for cybersecurity. And then I'll talk about attacks to cybersecurity, attacks to machine learning, and that will be adversarial machine learning. And then finally, the big challenge that we have, what do we do about fake news? Okay, so, and I have a number of my colleagues to thank. So this goes back to sort of 1990s, data mining, data science, security, and privacy. So I got started in this work back in 1996 when I gave a keynote address, IEEE 11.3 Data and Application Security Conference, and that was in Milan, Italy. So I talked about data mining, what are the security implications, and what about privacy, because we can put a lot of stuff together and infer information that is highly private. It was very new at the time. And then Professor Xingdong Wu, who is the uh, essentially the owner of IEEE ICDM, the founder. So he invited me to give a keynote address at PAKDD in Melbourne, Australia, 1998. And then I published what I would say landmark. I will tell you why I call it landmark, because I was a program director at NSF. And when you are a program director and when you publish a paper in CKDD, then of course everyone pays attention, right? So it has many citations, and that was like one of the early works that spawned this whole area. At the same time, IBM Almaden Research Center, Rakesh Agarwal and his colleagues, they coined the term privacy preserving data mining. How do you have privacy as well as do data mining? So you have the original data, you add some noise, perturbation, randomization, and then the modified data, and then you apply the data mining process, but you want to modify the data in such a way, add a privacy metric in such a way that the final modified result should be the same as the original, that if you hadn't added the privacy metric, because what's the point in adding a privacy metric when you get all different results? So then when I joined, so I was at NSF. Soon after that, I joined University of Texas at Dallas. And then we had a PhD student, myself and Dr. Murad Kantajalu, joined PhD student, Dr. Li Liu, and she worked on privacy preserving decision trees. So at that time, a lot of algorithms, privacy preserving association rule mining, decision trees, neural networks, and so on. So data mining, security, and privacy, right, exacerbated with big data and data science, because the more data you have, the more stuff that you can uncover. So we hosted an NSF workshop in big data security and privacy in September 2014. and presented the results to the interagency working group in February 2015 in Washington, D.C. Okay, so as a result of that workshop, we started a project, Privacy Aware Policy Based Quantified Self. I'm going to very briefly talk about my research, and then I'll talk about how we can support women. Okay, so we built this data management framework we designed and developed. But then we said, okay, there's lots of data being collected: health, fitness, location, social media, image, video, other sources, and they're all coming into our smartphone. And of course, some of the data, you can't store everything in the smartphone. It's stored in the cloud, and it could be encrypted. And through cloud-based services, we can access the data in the cloud. What we designed and developed is policy aware privacy aware, policy based. So we said policies have to govern everything. Whether you are doing data collection, what are the policies? Storage and access, what are the policies? Data analytics, what are the policies? Data sharing, again, what are the policies? So this is what we designed and developed, right? Because quantified self movement is a movement that has been developed by sociologists and psychologists. It's really great because it can get all this information about you and give you advice for your health, right? So, for instance, I love vanilla ice cream and milk chocolate. And so it'll be really good if my smartphone tells me if I'm eating chocolate, no, you're not supposed to eat that, right? But then imagine my privacy is going to be violated. Lots of information about me is collected, and that will be known to so many people. So that's why we are saying policies have to govern everything. Okay, that's one part. Another aspect of our research is that we are using data stream. How do we detect anomalies? It's nothing new. It's been around for a long, long time, right? But the only thing is, those days we built only one model, right? You can't develop, we didn't know how to develop multiple models, right? Yesterday it will say buy Microsoft stock. Today it's Google. Tomorrow it's Amazon. The next day it is, something else like Apple. So we need different models. So data is arriving in streams: financial data, network data, whatever, right? Big data, massive data streams. So what we do is look at the past, right? And we construct the model, train the model, and then we test. But the models are changing, right? Back in 1995, there was only one model. So continuous flow, very common in our connected world, massive amounts of data. So we build an ensemble of model. And these models talk to each other and they say, okay, this model is outdated, and they throw it away. And so because there's only finite number of models. So, and sometimes there could be a human in the loop. So we train all the models, the ensemble collection of models, and then we test. And then what we do? If we have attack traffic, we block and quarantine. Otherwise, it's benign traffic. Okay. So we applied this to insider threat detection, bad people pretending to be good people inside an organization. And so user is typing away, system calls and so on. We have iChunks, right? And that's for the training. And so we extract the features, we apply unsupervised learning, supervised learning, build an ensemble of models, and then throw away the bad models, right? Outdated models. And then I plus one chunk arrives, and then we do the testing. Um, and then we decide, right? It's insider or not. Right? So we applied number of applications. This is just one such application. Now imagine on the other side, right? What happens if your machine learning algorithms are attacked? That's a very real possibility because we are applying machine learning everywhere. Even ChatGPT, we are very worried, right? ChatGPT could be attacked. It can give you all kinds of incorrect results. So these machine learning algorithms could be attacked. The adversaries will be attacking. They are going to learn about our models, and we have to learn about that, what the adversary is up to. So here we have all the red crosses are bad instances, the blue circles are good instances. And this is, we use support vector machine. This is the boundary line. So what is adversarial learning? It's not concept drift. It's not online learning. Adversary adapts to avoid being detected during training time or data poisoning during testing time. So it becomes a game between us and the adversary. See what happens. See anything, these are the red instances. Above this assuming above the support vector machine boundary line, right? So look what happens. Adversary is trying to push 1, 2, 3, 4, 5 instances below this boundary line. So now these bad instances would be considered as good instances, right? So that is what we don't want. So we've got to learn what is the adversary trying to do. And then what we do is, I don't think, yeah, so what we are doing, so this is a little bit confusing because I took the reverse here, right? The green circles are good instances, the red crosses are bad instances. Okay, so this is the support vector machine original line. Everything below this is bad. Above this is good, this line. So here it's better explained, right? Below this line, this is the original line. Forget about the blue line now. This is the original line. Anything below this is bad instances, and above green circles, good instances. So so adversary is trying to figure out where our machine support vector machine boundary and pushing the bad instances, to good instances. And so black dash line is a standard support vector machine. What we are trying to do is, we play games with the adversary and we have to figure out where to move the line, right? So we find this blue line. That is where we want to push the support vector machine boundary line. Anything below the blue line is bad instances, and anything above the blue line is good instances. So a lot of the bad instances would be caught, even though they are trying to push, right? The bad instances they are trying to push, but some of these bad instances are going to be caught. But you can ask the question, why don't we move this blue line up here? If we move this blue line up here, then all the good instances will be known as bad instances, right? Because the blue line is right here. So if you move it here, we are going to have lots and lots of false positives. All the good ones are going to be thought of as bad, right? So the challenge for us is a lot of mathematical computations. First, we've got to also figure out what's the attack model. So a lot of challenges and a lot of computations, and we've got to figure out exactly where to place this blue line. Okay, so what about fake news and fairness, right? That's a big area now. Machine learning techniques being applied to detect fake news, training from numerous articles and then testing, and data provenance for determining the source. Security attacks exacerbate the problem, malicious bot creating fake news. So major challenge faced by AI and security researchers, including attacks to large language models. So machine learning techniques have to be fair and have to include what? A fairness metric, a fairness parameter. And then we have to adapt the algorithms to take this fairness parameter into consideration. We need AI ML to be secure, fair, ensure accuracy, and preserved privacy. So that's a challenge. How do we bring in this AI ML algorithms? They have to be secure, no attacks. They've got to be private, no sensitive information being given out, and they have to be fair, not discriminate against women and underrepresented minority communities. Okay, so one of the applications we are working on, funded by United States Department of Transportation, we are now part of the US DOT $20 million Center for Transportation System Security with Clemson University leading the effort. So I just want to just mention that's our current research. So very active now in applying all what I discussed previously, privacy, security, and fairness, to Internet of transportation systems. Okay, so summary and directions for security and AI. Again, numerous benefits for AI, including for social good, right? Without a doubt, AI has so many applications. AI and machine learning also applied in cybersecurity. But privacy could be violated because of machine learning. We talked about it. AI techniques could be attacked. Fake news, fairness, another major challenge, right? So we need integrated and scalable solutions, integrating of data science, AI, and cybersecurity, and the cloud. So, and we are applying all of this to transportation systems. Okay, so I've now talked for about 15 minutes and I've got another 15 minutes, but So I'll take another 10 minutes and talk about how we can support women and underrepresented minority communities. Okay, first of all, a little bit about myself. How did I get here? I am of Sri Lankan Tamil origin, right? Uh, so Sri Lanka is a tiny, it used to be called Ceylon, tiny island, the south of India. And so I married when I was 20 in 1975, while I was finishing my BS in mathematics and physics at the University of Ceylon. It's now University of Sri Lanka. My husband is also of Tamil origin, and he was finishing his PhD in physics at the University of Cambridge in England. Okay, so it was an arranged marriage. We moved to University of Bristol, England, soon after I graduated from my undergraduate, and I started my graduate studies right in England. And then after 5 years, in 1990, so my husband first worked as postdoctoral fellow, and then he was a research fellow. And then we moved to New Mexico in the United States in 1990. As I finished my PhD, we had better opportunities. So I was offered a tenure track assistant professor position at New Mexico Tech in Socorro. But I turned down the offer because my son was a baby. And so I felt that I couldn't cope with tenure and so on. So I took visiting faculty positions to be a little bit more relaxed, right? So that was a career choice I made, Socorro. And later, my husband moved to 3M in Minneapolis. So I, followed him. And then I worked at University of Minnesota for a couple of years. And so for 3 years, I was working as visiting faculty, but I was always working on my papers and learning and doing research and getting into some new areas. But my PhD was in theory of computation. So I also got into algorithmic information theory and so on. And so then I wanted to also get into commercial industry, right? And so I wanted to change. And so Control Data Corporation, it was at that time, I'm sure many of you all wouldn't have heard of it. It was a number 3 computer company after IBM, DEC, and Control Data. Only IBM is still around. Okay. So I joined as senior software developer for developing a computer network, which was very new at the time. So I worked on a computer network called CDCnet. And then I had a lucky break. It came in fall 1985 because I really wanted to get back into research. I liked development, and we were releasing our first product December 1985. So a lot of my work, but I had more work to do for the second release and so on. But then I wanted to get back full time into research. By then I was an adjunct faculty at the University of Minnesota, and I was doing some research there. But I wanted a job where I can do research while I'm working in my job. So 3 great things happened. I became a US citizen in fall 1985. And then Honeywell won the US Air Force contract to design a high assurance database system. And then Honeywell interviewed me and they wanted to hire me. So all 3 things had to happen: US citizenship, Honeywell getting the contract, and Honeywell hiring me. I don't know. You can compute the probability of that happening. Very, very, very small. So I've been working in cybersecurity and data science, AI. It used to be computer security and data management. And so at Honeywell, and then from there, I went to MITRE Corporation, a federal research lab in Massachusetts, Bedford, near Boston, Massachusetts. Then for 3 years, I took an assignment and went to National Science Foundation for 3 years. And then UT Dallas asked me to come and head the Cybersecurity Institute, to found and head it. And so I decided it would be a nice change to come and do it for a few years. And that was in 2004 fall. And now I'm 19 years. I'm still at UT Dallas because I love the work I do and the environment so much. And I get to work with women in data science and women in data mining, data science, and also women in cybersecurity. So I'm very involved. Now, my advice to women, right? Why AI and security for a woman? First of all, we know that knowledge is power, right? Cybersecurity and AI and data science, like here, ICDM, are highly intellectual fields. I mean, you need to have, some intelligence to thrive in these areas that integrate multiple disciplines like statistics, machine learning, AI, data management, all of these disciplines with security. And numerous opportunities, because remember, AI is being applied now for data science AI for every area: healthcare, finance, retail, marketing, oh gosh, everything, manufacturing, and also for security. So they are being applied for so many areas, but every time you apply AI, the AI techniques, AI algorithms could be attacked, right? So financial algorithms, healthcare algorithms, all of those AI algorithms could be attacked, and they can give you incorrect results, right? Instead of telling you to buy Microsoft, it's going to tell you totally different and say buy Apple, right? Or saying, instead of saying that you have cancer, it's going to say, oh, you have just some stomach indigestion or something, and that could cause death. So you have to make sure that AI security, these AI algorithms are secure, right? But and these security and AI, they are high paying jobs, right? Not 20 or 30,000, but it could give you, 200, 300, if you're really good, even more than that, $1,000 in the United States. And for women, I tell that to all the women. I've been saying this for, I don't know, 20 years. Financial independence is a must for every woman. When I say financial independence, it's not just, having enough money to survive. No, you have to have enough money to thrive, not just, pay the mortgage and so on, and pay something for the children, what they need. No, you need to have money to thrive. And for that, you need a high paying job, intellectual, and also something of intellectual value. Because I'm not telling all the women, right, go and get divorced or something, right? No, because for me, marriage is very important. It's a very sacred institution. However, if you are in an abusive relationship, and so many women, some men are also, but mostly women are in abusive relationships, and if they don't, if they have enough, and most of them are staying in these relationships because they have no other way out. But if you have the financial independence, you can walk out anytime, right? Okay, there are some other issues because you could have a crazy spouse who could come after you. I mean, those things do happen, but in general, we have financial independence, you can walk out. So, having financial independence, I believe, is a must for every woman. AI has, again, now coming back to intellectual, AI has applications in medicine to law to engineering, marketing, sales, social science, and cybersecurity. Both cybersecurity and AI have many options, from research and academia to product development, startup to government with substantial funding. Millennial women and beyond, right? They have the flexibility and freedom. They can choose careers and have female role models, right? There are more and more females now getting into good positions. That we women, right? I'm a I'm a baby boomer, right in the middle of the baby boomers, right? From 1946 to 64. So I'm right in the middle. So to start up, right. So we baby boomers didn't have all this support systems. So we had to sort of figure out what to do. And security and AI, flexible field. But although today, these days after the pandemic, we're all working from home. Most of, not all the time, but we have the flexibility. But before that, right, everybody had to show up at work. But if you're working in security and AI, you can also work from home. So that's not so much of a big plus right now. But in any case, you can have the best of all the worlds. You can work in cybersecurity and AI at the integration. And one thing I cannot emphasize more. To have a successful career, you must have a mentor who will watch out for you. Because there are enough people who are going to spread bad things about you. If they want the same position that you want, and they can say bad things about you. And if you are a woman, especially if you are a woman of color, right, then it becomes very difficult because people could believe, right? And in a way, some time ago, it happened to me. So there is this thing called subconscious bias. They are not really purposely trying to put you down, but there is this subconscious bias. And so I was very fortunate. I had a woman, I mean, this woman who was a little senior to me. I did some work for her. She really felt very strongly and supportive of me, and so she spoke up for me. And I had a mentor, a man. He was from UC Berkeley, Professor C.V. Ramamurthy. He was always there to tell me what are the steps I need to take, like IEEE fellow, ACM fellow. He was not living, but IEEE Technical Achievement Award. And so he sort of trained me, and so I now help other women. Okay, so that is important. You must have a mentor, It doesn't have to be a female mentor, it could be a male mentor. So, male and female would be very good. So, I cannot overemphasize this enough. Okay, so that's the end of my presentation. Of course, there are several people I have to thank. And yeah, I'm supposed to be talking for about half an hour. And so, yes. So, and again, I'm Bhavani Thuraisingham from University of Texas at Dallas. And in about 5 or 10 minutes, I'm going to join the conference live and hopefully see everyone then. And thank you very much. Thank you. Bye. Good night, or it's good morning there in. I think it's in China, Shanghai. Right, it's in Shanghai. So I'm sorry that I couldn't make it in person because oh, I love Shanghai. It's one of my favorite cities, and so it's sorry that I can't make it, but anyway, I'll see you virtually. Thank you. Bye.